Once, even though people will probably wonder INSE. Okay, before we start, just a reminder that next week there's no class. It's Easter holiday. And then what the university does is they make that day up. So I'll just say so next week there's no class. The week after there'll be just the normal class on Friday. And then the week after that there'll be a class on Tuesday instead of Friday. And it's for any classes that you have on Friday will be on that Tuesday, basically. So it's a little confusing. Now that Tuesday class, I'm not going to actually hold an in-person class. What I'll do is I'll have you watch, there's 2 videos that are on the Moodle that you can watch instead of attending class, okay? So you are responsible for this, and the last day of class is technically that Tuesday. But anyways, 2 weeks from now on Friday will be our last in-person meeting. Okay. If you didn't catch all that, it doesn't matter. I'll tell you again in 2 weeks. So, but yeah. Okay. Is there any questions before we start about anything? I don't have my calendar. Just let me. I'll tell you again with the exact dates. All right. So today's March 31st. So we have class, obviously. Next Friday is April 7th. There's no class because of Easter. April 14th, there is class, just like normal. And then that's normally like the last week of classes, except for if you have a Monday class, then the Monday after will be the 17th. And if you have Monday classes, it doesn't apply to us, but if you happen to have Monday classes, you'll still have class on Monday. Tuesday is a makeup day for anyone who has a class on Friday. So Tuesday, April 18th, it will be like a Friday, even though it's a Tuesday. It'll be like a Friday. Then the day after is the 19th, and then that's when exams. I think they give you 1 day off, and then the exams start or something like that. Yeah. So there is. I don't have the link. I'll show you. You can find this somewhere in Concordia's mess of website. So I guess the path is kind of like here, but this is a good thing this is useful. I always look at it all the time. And so it tells you everything that you want to know about stuff. So you can see that Friday, the university is closed on April 7th. Then Tuesday, April 18th is a makeup day for classes scheduled on April 7th, which is the Friday. So that's us. So yeah. And then the 18th, there's nothing. And then the 20th is when your first exam could be. Yeah, so April 18th applies to us. We do have a class scheduled for that day, but I'm not going to bring you in person. So I'll just have you watch some YouTube videos. So I'll wrap the class up on whatever the Friday is right before this. So that's when, yeah, that will be the last. That will be kind of like the last class. But then you'll have some videos to watch. And the videos, I'll say more than, I'll give you kind of like a preview of them, but I will ask you some exam questions about the videos, so they are included in the course material. But at the same time, because you're watching them and then not coming back to me with questions, there'll be high-level questions. I'm not going to ask you really deep questions about them, but you are responsible for getting the main ideas out of those videos. They're on ethics. Yeah. Okay. So it's a little confusing, but anyways. Any other questions? Okay, good. Okay, I'm just thinking. Okay, there's one other question that you would be asking me next week, but because we don't have a class, you're not going to ask it to me next week, and then the following Friday you're going to be sweating a lot because you'll want to ask it, but it's not occurring to you to ask it until now, so I'm just going to ask it on your behalf. So as you know, the project's due the last day of class, so that would be that Tuesday, that weird Tuesday. So I'll see you on the Friday 3 or 4 days before it's due, and you're going to be like, I have 5 exams and 3 projects due. Can I please hand it in a little late? And if we had that conversation, then I would say, yeah, it's fine. So what you can do is, Does someone remember when our actual exam is? 21? Yeah. So 21 is a Friday. So we'll have class on the 14th. You'll have a virtual class on the 18th, the Tuesday. You'll have your actual exam on the 21st. So if you want to hand your projects in, if you want to take the weekend, so you'll have your exam on Friday. It will give you that whole week, but you'll probably be studying, and then you can hand them in on like the 24th kind of thing. And anytime, it doesn't matter, whenever, okay? So I'll make it sort of official on the website. Technically, I'm not allowed to have a due date in the exam period, so I'll phrase it as I won't apply any penalty if you get it to me by the 24th. It's still officially due on the last day of class, but there will be no penalty if you get it to me by that time. Does that work for everyone? Yes. Okay, good. You're welcome. Okay. Remember that when the course evaluations come. Yeah. Okay. All right. So we'll jump back into the material. So the last two lectures, well, the last two in-person lectures are going to be continuing this idea of policies. So we looked at airport security last class, and now we're going to do the same, but we're going to look at technical policies. Okay. But the reason I'm putting them side by side is, even though this is technical, it actually is exactly the same thing. Some people some time ago sat down and they said, okay, we got to figure out what our policy is about this, when we should accept things, when we should reject things. They wrote something down. It probably wasn't perfect because there was a lot of problems with it. The problems, you could argue, they're not like flaws in the policy. It's just that the way people thought it worked and the way it actually worked was different. And it took a couple decades of like security flaws and vulnerabilities and things like that before people like kind of got their heads around exactly what the policy is. Okay. All right. Okay. So the policies we're going to look at have to do with browsers. And so I picked two out. So today we'll talk about cookies. So cookies are hopefully something you're familiar with after A2. Okay, you should now have the basics, and we'll go over all the background and details, what they are and how they work. And the other one is called the same origin policy. It's kind of like the policy for cookies, but it applies to JavaScript. Okay, so it's about containing JavaScript when it's running on a page, and what's it allowed to access and what it's not allowed to access and things like that. Okay, and we'll talk about that one next class. Okay, so browsers, they kind of started in the 90s. So like for example, if you go to Concordia, you might go to www.concordia.ca. What's www stand for? World Wide Web. What does that have to do with anything? Like, why do we call it, like, what is the World Wide Web? So it turns out it's actually the very first browser. So when we had the internet, in the sense that you could use TCP to talk to computers, okay? But there wasn't this notion of like a website. So you would go to an address, and then that address would have like a page, and then you would render that page client side, and you would look at the page, and you might click on something on the page, and then it would take you to a new page. Okay, so there wasn't that notion. There were things like email and things like that were earlier, but this notion of like what we think of the internet, like actual websites, that didn't really start until the 1990s. And the very first browser was called the World Wide Web. And so that's where that www came from. So people would put their websites at www.whatever as a reference to this browser. Anyways, this browser wasn't like very popular. It was more like something that like people who are really into the internet and technology and stuff, they use. It wasn't until Mosaic came out and then Netscape, so they came in 93, 94, they were like the breakthrough browser. So that was like the browser that you might actually install in your computer, you might actually use. It was the one that like kind of reached mainstream. So when the internet went mainstream, it was with those two browsers. And then Internet Explorer followed shortly after in 95. And then there was a war between Netscape. So Mosaic kind of turned into Netscape. So once Netscape came, then there was no more Mosaic, essentially. And so it was sort of a war between Netscape and Internet Explorer. There was lawsuits and antitrust suits and all sorts of crazy stuff that happened. And then later, Apple, they added their own. So instead of using Netscape on Apple, you could use Safari, and Firefox came out. Firefox is Netscape basically died at a certain point, and then Firefox kind of bought up the technology. That I don't know if buy is the right word, but anyways, they adopted the technology behind Netscape, and so Firefox is kind of an extension of Netscape. And then you have the Chrome browser, Google Chrome, and there's other ones too, like Opera. I didn't talk about. So today, Chrome is apparently the most popular, and then Microsoft and Safari, and then Firefox, Opera, and 360 Safe. I don't even know what that is. Never heard of it. But anyways, okay. So now, where do cookies fit in? Okay, were cookies in www? And so the answer is no. Okay, so at the start of the web, there were no cookies. Okay, cookies were invented by Netscape. So they invented it. They came up with a standard for it. They came up with a policy for how cookies should behave, which is sort of in the standard, but behind the standard, there's an idea which we would call a policy, and so that came out in like '94, and they implemented it and they pushed it, and then Microsoft adopted it soon after, and then we've had cookies ever since. Okay, so Netscape in '94 they invented cookies, and in that implementation and spec there's a policy that we'll talk about, and then the next year they came out with a similar policy for what's called the same origin, and we'll talk about that next class. But there's a reason I'm talking about these two, because they're very similar, and they both look at origins. Origins is an important concept. One is applying to whether I should send cookies or not, and the other one's being applied to I'm running some scripting, what's it allowed to see? And the basic idea is that it can't see anything that's not in the same origin as itself. Okay, so browser policies, this is maybe more for same origin, but I'll just get this concept sort of out there. We talked a bit about this in HTTPS. So we said, hey, let's say you have a website and you download index.html. It comes to you over SSL, so that's fine, it's secure. But then it turns around and it starts loading images and videos and JavaScript, and it's getting it from all sorts of different websites. And sometimes those are coming down also over SSL. Sometimes they're not coming down over HTTP, they're just coming over HTTP. What do? Do you show the lock or do you not show the lock? And the answer was, well, there's a distinction between what we call a passive resource and an active resource, okay? So if it's JavaScript and it's coming down, and it's not coming down encrypted, that means there's no integrity on it. That means anyone that's in the middle could change that JavaScript. If they change the JavaScript, then that once it runs, it could actually, even all the things that did come over HTTPS, it has the power to we'll talk about this next class, but it can walk around what's called the DOM tree, and it can look at things and change things. So it could actually change the complete website. It can make it look completely different, even the stuff that came down. So it's really important that type of stuff comes down over a secure connection if you want to show the lock and say the whole site is secure. Okay, so those are active resources. The main ones are scripts, so JavaScript. There's older things like Flash and ActiveX that aren't really used that much. Style sheets are considered active, so this is like the things that set fonts and things like that. It looks a lot like HTML style sheets, like you wouldn't think that they would be active, but now they've become powerful enough and they have some scripting capabilities that we consider them active. And the other type of active resource is a connection that's opened by JavaScript. So what JavaScript can do is it can go and say, I want to grab this image from this place, okay? And the way it does it is different than if your browser was doing it. So if your browser was doing it, it would do just a get over HTTP. If JavaScript's doing it, it's still the same protocol, but it opens it up with this XML HTTP request. And sometimes we're more cautious about these types of gets as opposed to HTTP. Okay, and you'll see why, maybe more so next lecture, but you'll see why these things are dangerous. It has to do with what's called cross-site scripting attacks. Okay, passive is like image, video, so now you can embed MP4s, like you just do a video tag, audio, same idea. And so that's your content. Now, with request and response, so a request is when I send something to the server, and the response is what I get back. All the content is what's inside the request. Well, the request is for the content, and then the content itself is in the response. Okay, so the content comes down as the response. But think of it as an envelope. So the content is in the envelope of the response, but you could have stuff that's written on the outside of the envelope. Okay, so we call this meta content or headers. Okay, and so this is where cookies, for example, show up. So cookies aren't sent. It's not like a file that's sent to you. Okay, it's like I'm just sending you a JPEG, but the cookie is in the header of the response that's giving the JPEG to you. Okay, or the cookie's in the request for the JPEG. Okay, so it's being sent in these header things. And then there's other stuff like we talked about with Tor. When you get a request, it will say like, I'm Safari and I'm version this or whatever, right? And that can break anonymity because your browser version might be different than other people. And so what Tor does is it makes all the user agents look exactly the same. But anyway, that user information that's being passed, that's also being passed in a header. There's a referrer that's sort of, we'll see later where that comes up. But that's basically, what's the website, like if you do a new request, you want to get, like you click on a link, right? Now you're doing a new GET request. What was the website that referred you to it? What website were you on when you clicked that link? That goes in the refer field. So anyway, these are the kinds of things that show up in headers. There's tons more. There's like 24, 30 like common headers. These are just a few of them. Okay, so the general security goals for all your browser stuff, so both the cookie stuff and the same origin. If we think about Stride, what are we tackling in terms of Stride? And so usually it's one of two things. So one is tampering. So if the website sends something, that's what it intends for the user to see. Okay, and if somehow I'm able to change what it is that the user is able to see, that would be a tampering attack. Okay. And then the other one is information disclosure. So as a general rule, if, let's say I have two tabs open, one's going to Concordia, one's going to Facebook, Facebook shouldn't be able to see what I'm doing in my Concordia tab, right? So that's fine. But then what if it's mixed content, like Concordia has a Facebook like button on it? Then is Facebook able to see what's going on in Concordia, or is Concordia able to see what I'm doing with, like every time I click the like button, does Concordia see it? Like that type of thing, okay? So we're going to talk about all the different, there's no simple answer to that question. It depends a lot on how you set it up. But there are ways to isolate them, and there's ways to have them communicate if you want them to communicate. The other one that I did mention is sometimes escalation of privilege. So if you're able to, if I'm trying to constrain you and say that you're not allowed to break out of this container and you're able to, then we would consider that escalation of privilege. But I didn't list it explicitly. Okay, so just as a thought experiment, just think about this. So I go to Gmail. It says, okay, log in. So that's fine. So I send my username. I send my password. Now I'm logged in. It goes and it checks its password file. It sees that my password matches the hash that it has stored, and it logs me in, and it dumps me into my inbox. Okay? And now what I'm going to do is I'm going to click on that very first message. Okay? All right, so I'm logged in. I click the first message in my inbox. Do I have to log in again? So it just takes me and shows me the first message, right? So when it showed me the inbox, it knew who I was because I just gave it my username and password, okay? But now that I'm looking at my inbox and I go from my inbox to that first message, I'm not sending my username and password again, right? At least it's not asking me to type it in, right? So how does it know that I'm the same person? I mean, there's millions of people that are accessing their inbox at the exact same time, right? How do they know that I'm the person that just logged in? So that is an open question if anyone wants to answer it. Okay. So it has something to do with cookies, sessions. You might think it's based on like IP address, or like, oh, this is a request that's coming from the same IP address. Why doesn't that work? Okay, so you could have lots and lots of people on the same IP address, right? So if you have a Wi-Fi router at home, basically everyone that's on it will have the same IP address facing out because of that addressing. And so, and two people in the same house could be going to Gmail at the same time, and you don't want that confused, okay? So it's going to have to do with cookies. Okay. All right, so I have a video that's kind of cheesy, but anyways, it's just a fun thing. I thought I would show it, and the sound I think is working. It's just like 2 minutes long.
Most of us think of Google as a search engine, but it's also an ad agency. Hi there, I'm Jeremy Clark, a professor at the Concordia Institute for Information Systems Engineering.
It's a while
Today
ago.
we're going to demystify internet cookies. So all of you have certainly heard about the delicious things of cookies, and most of you have heard about internet cookies. To help understand this concept, I'm going to tell you a little story about Alice. So let's say that Alice gets a brand new tablet. She opens a box, turns it on for the very first time. At this point, she's completely anonymous. She decides she wants to go and find some news to buy. So she goes over to Google, and at this point, a cookie's born. Think of a cookie as a serial number that websites assign to their users to track them around their platform. As Alice looks through her search result, she notices a pair of boots from her favorite shoe store and clicks on the link. By default, a cookie from one website can't follow you onto another website. However, Alice's favorite shoe company, like most of the top-leading websites, has a business relationship with Google. This allows Google's cookie to follow Alice through the virtual doors of the shoe store, like a little digital stalker. Alice gets bored of looking for boots, so she decides to go over to a message board to chat about her favorite show, Black Mirror. On the message board, she sees an ad for the exact boot she was just looking at. So what's going on here? Most of us think of Google as a search engine, but it's also an ad agency. The chat room in this case has outsourced its apps to Google. And because Google has a cookie that followed Alice from the search page to the shoe site and now to the message board, it knows exactly what ads it can serve to Alice that she's likely to click on. Using cookies in this way is prevalent on the modern web. Of the million most popular websites, Google can trace you across about 50 to 80% of them, while Facebook can track you across a third. Now, all of this may sound very scary. You should know that cookies are primarily used for advertising. However, there are more nefarious uses. For example, websites have started selling digital dossiers to political campaigns for micro-targeting. Now, you may be wondering what you can do to stop this. The truth is, it's pretty much impossible to live a cookie-free existence, as cookies also serve practical functions that make the web easier to use. However, there are some small tweaks you can make to your browser settings to help protect your privacy. First, you should disable third-party cookies. Second, you should enable Do Not Track, which prevents companies that are compliant with Canadian law from using cookies to trace you. The third thing you might use is private browsing mode, which gives you a fresh identity, sort of like when Alice turned on her new tablet for the first time. This is why digital privacy is such an important issue moving forward. And that's how the cookie crumbles.
All right, so it's a cute video. Obviously, there's no technical detail there, but we'll go through the technical details here. But it gives you a sort of high-level view of what cookies are and how they're used. Okay, so a cookie, one thing that you might have got from the video is it's basically just a number. It's data that's assigned to you. It comes in a key value form. So a key is like a label, and then the data is the data itself. Okay, so the key might be UID for user ID, and then the user ID might be 1, 2, 3, 4, 5, 6. Okay, so that's really all the cookie is. There's a bit more in the cookie we'll see in a second, but that's the sort of model to think about what it is. Okay, how do you get a cookie? Like, say my user ID is 1, 2, 3, 4, 5, 6. Who picked 1, 2, 3, 4, 5, 6 for me? Okay, so it's a server. Okay, so the server's picking the cookie values. It's not you. You're not volunteering that. The server's picking it for you. Where are the cookies stored? So that 1, 2, 3, 4, 5, 6, is that stored on the server, or is it stored on the client? Okay. So actually both answers are probably correct, but it's mainly stored on the client. So the server will send you a cookie. It will ask your client to store it on its behalf. And your client either will or it won't, depending on what policies it has set up. Now, in order for that to be useful to the server, it probably wants to remember what cookie it gave you, okay? So just like it remembers your password, or at least a hash of your password, it probably has a file in the back end somewhere with all the cookies it gave out to all the different people so that it can keep track of it. Okay, so the cookie, both the key and the value for the cookie is chosen by the server, so it can choose whatever it wants. What it does is, how it gets to your browser is when you request information. If you never visited a website, you can't have a cookie for that website, okay? With one exception, which are called third-party cookies, which we'll see later, but just in general, and they're usually always disabled anyways. So you won't get a cookie until you visit the website, and it's because you ask the website for something. When it sends that first response back, it throws the cookie in, okay? So it's like, here's that JPEG you asked for. By the way, in the header of the JPEG, I'm going to put this set cookie request. And I'm going to say, I want to set a cookie. This is the value. This is the key for it. And then my browser generally will store that cookie, okay? Unless if I have something like Ghostery installed and I have the right settings turned on. All right, and the browser will also remember what website was I visiting when I picked this cookie up, okay? And we'll see we'll see why that's important. Then what your browser will do is every time you go back to, for now we'll just say the same website. There's a nuance there that we'll see in a bit, but basically you go back to the same website. What your browser will do is it will go through all its cookies and say, hey, do I have any cookies that match this website? Okay, so I'm going back to Google and I have a cookie from Google. It will find it and it will automatically put it into my request. So my request goes back to Google, and now in the header of my request, it throws in every single cookie I have for Google so that when Google gets that request, it can look through them and it can see which cookies are there, okay, what the values are. All right, and the policy is basically going to be like, I have a bunch of cookies, I'm going to a website, am I sending the cookie, yes or no? That's basically what the policy is, okay? So we have to make a decision about, like, it might be obvious if I picked up a cookie from google.com and I'm going back to google.com, then I'll send that cookie. So that's fine. But if I picked up a cookie at mail.google.com and I'm going to images.google.com, do I send it or not? Right? So that maybe is not so obvious, right, what the answer should be in that case. Okay, so that's why there's a policy for it. It's not just a simple policy. Okay, so when exactly will the browser send cookies back? And so that's what the cookie policy is for. So just a kind of visualization. So I go to mail.google.com, I send a request for whatever, the login screen or my inbox or whatever it is. What mail.google will do is, if it's never seen me before, it will say, okay, I've never seen this person before, but I want to know who they are. And so what I'm going to do is I'm going to just I'm going to make up a cookie. And a cookie value is usually, so cookies, I should note, aren't always used for tracking. So that's one of the purposes for cookies. Somewhere later I have a slide with some of the other ones. But other things could be like, say you go to a website and it's like, do you want the English or French version? So you click English, right? Then it remembers that. So like as you're on the website, it remembers that you want English. Even if you like close the website down and come back tomorrow, it might still remember that you want English, right? But you never logged in, you never created a username, password, you don't have a profile for the site. So how is it remembering it? Well, it's using cookies, okay? So cookies aren't always about, tracking and advertising and all of that stuff. Sometimes they're for things like that. But anyways, what Google might do is they might say, okay, I don't know who this person is, so I'm going to create a new entry. I'll just call them unknown for now. Maybe eventually they'll log in and then I'll know who they are, okay? But I'll just mark them as unknown. I'll make up an SID for them. So like think of the middle one, for example, the D4C or whatever. And then if I'm going to use this as a basically like think of the case where I log in. Now I have a session ID that's in a cookie. And so we're passing this cookie back and forth. And that's what's keeping me logged in. What if I steal that value from you? if I steal that, like I don't know your username and password, but I'm able to steal that cookie value, then when I log in, I send that cookie instead of my own cookie. So I replace my cookie, my user ID with your user ID, and then I just go to Google. What happens? So the answer is it just logs you in, right? It thinks that, I mean, the session ID, that's what it's there for, right? It's about maintaining that login. And so if I steal your cookie, right, I'm stealing your session. We call it session hijacking, right? I stole it. So anyway, so these session IDs need to be hard to guess. So one thing I might do is I might just try a random session ID and see if it matches any user that's logged in. Okay, so these need to be kind of like passwords. They're big, they're long, they're random. Okay, so then the response goes back and the website will say, okay, I want to set this cookie and the session ID is this value. Okay, now let's assume that we're accessing mail.google.com over HTTPS. Okay, now we know that, for example, some things are in the encrypted tunnel and some things aren't. Okay, so for example, the actual website that I get back, that's in the encrypted tunnel. The fact that I'm going to mail.google.com or its IP address, that cannot be in the tunnel, right? Because otherwise the packet won't get to where it goes, okay? What about the header of an HTTP request or response? Would that be in the tunnel or out? Is it on the inside of the envelope or the outside of the envelope? Say it loud. Okay, why would it be outside? Okay. So the header is helping route the protocol. It would have to be on the outside. Okay. Is the cookie itself helping route the packet? It's not. Okay. So if it were, at least if it were on the inside, it's not like it would be unroutable. You agree? Yeah. Okay. But at the same time, it is a header. We call it a header, right? And header, when I think of headers, I think of outsides of envelopes. Okay. So anyways, it could go either way. But what I'll tell you is if it weren't encrypted, we'd be in a lot of trouble, because then I could just, if I'm a Wi-Fi router and I see all this information go by, I can just pull your session ID out and then I can log in as you, okay? So the answer is that it's actually encrypted, okay? So it is in the tunnel, it is encrypted even though it's part of the header. That whole thing is encrypted, that whole layer of the protocol is inside the tunnel, okay? Okay, so, and it has to go, otherwise this whole session ID thing basically doesn't work. Now, you might not be old enough to remember, but there was a time when most of the web didn't actually run on HTTPS, okay? So what would happen is you might go to a website like mail.google.com, and when it asks for your username and password, it shows the lock. You type your username and password in, it goes over SSL because we want to protect the password. But then once it logs you in and it knows who you are, then it redirects you to just HTTP. So you'll look at your inbox and now you're back on HTTP, okay? And then you click on the first message in your inbox. We're using cookies, right, to maintain that persistence of that session. But that request for that first message in your inbox, that's going over HTTP. Now, why would they do it? It was mainly for performance. So they were worried that, like, if we encrypt everything, it's going to be too much performance. So Facebook, Twitter, like social media, they all worked this way. So they would take your password over HTTPS, but then once you were logged in, then they would serve everything over HTTP. Okay. So what could go wrong in this case? Is that secure? Is it fine once you get the password? Okay. So then you can session hijack, right? So what would you need to session hijack? You just have to get in the middle, basically. Okay, if you were in the middle of the conversation, then you would see the plain text as it goes by. You could pull the cookie out and then you could log in. So the way it worked is that people knew that this was a problem. Facebook knew it, right? It's just that they thought, you know, what's the chances that someone actually gets in the middle? Like that, we say it as if, like, very casually. It was the whole root node of our attack tree earlier in the class, you know, but it's not so easy to get in the middle of a conversation. Like you have to be like an elite hacker, like in order to do that, right? So that was their feeling, and Facebook wasn't valuable enough. Who cares? Like some people's sessions get hijacked, whatever. It's not like an everyday kind of thing. Okay, so that was the attitude, and it persisted for a couple of years. Security people are like, no, you should send these cookies over HTTPS. Of course, if the cookies are attached to every request, then that means you're sending every request over HTTPS, right? Which means that basically you're running your whole website over HTTPS. Maybe when you look at your friend's photos, the data itself comes down as HTTP, but everything else needs to come down over HTTPS. So then what someone did is they said, this man in the middle thing is actually easier than people think. What you can do is if you go to like a public Wi-Fi router, and you're just a user, you're not the administrator, you don't have to touch the router, but what you can do is you can poison the routing table inside the router, and you can get everybody routed through you, okay? You don't have to do anything special. You can just do it with your computer. You exchange the right protocol messages, and now all of a sudden everyone's routed through you, and then you can hijack their sessions. And so what they did is they wrote this extension for Firefox. It was called Firesheep. And all you would do is you would install it like Ghostery, which you did. It's just an extension. Okay, so like any user could install it, and you would just go to Starbucks, you would open the extension, and boom, magically it would say, here's 10 people that are on Facebook. And it would have their name and their profile picture. And then you would just double click on whoever you wanted, and then it would log you in. And now you were logged in as them. Right? So they took this concept, like this elite hacker thing, they made it so simple that anybody could do it, right? Then it was all over the news and everyone was freaking out about it. And then Facebook's like, okay, we gotta turn HTTPS on everywhere, right? And they did it. They did it within weeks of this coming out, and Twitter did it, and then it started going to like the New York Times. Like, who cares if someone hijacks your session? They get your crossword scores for the last 6 months. Like, who cares? But they're like, no, this is serious enough. We need to turn it on. And so now there was basically like 2 pushes towards SSL adoption. This was the first wave. So when this happened, any website that had like content that was personalized went to HTTPS precisely because of this Firesheep extension. And then the second thing was there was this person who worked at the NSA named Edward Snowden. There's a movie about him, you might have seen it, and he leaked a bunch of stuff that the US government was doing to circumvent HTTPS. And so that was the second wave. Then that's when like all your news websites and Wikipedia and all those websites, they went to HTTPS everywhere, even if they weren't necessarily logging users in. And so now it's like you go to Concordia, it's over HTTPS, right? It never used to be that way. It used to be like just thought of, you're taking credit card numbers or passwords off people, that's what it's for. It's not like a general privacy protocol for everywhere. Okay, so now what your browser does is it gets this response, and the website is like, okay, I want you to set this cookie. And so your browser by default will be just like, fine, I'll add it to my cookie jar, as it's called. And so now I have a cookie jar, and it's mail.google.com, and this is the cookie. Okay, so SID and the value. Then if I go back to mail.google.com, what I'll do is my browser will first intercept that, and it'll say, okay, we got to check the cookie jar. And then it will go through the cookie jar, and it will say, hey, you have a cookie for mail.google.com. You're going to mail.google.com. We better throw that cookie in. And so it will put it in the header of the next request that you make to that website, okay? And it will keep doing that until either you get rid of the cookie or it expires, and I'll show you like a couple things like around that. Okay, then when that request comes to mail.google.com, it decrypts it, right? It takes off the HTTPS. It says, oh, there's a cookie here, okay? I know who this person is. Let me go look in the table, and I'm like, oh yeah, I have this cookie. I assigned it to this unknown user. Okay, so I don't know who the person is, but I know that they were the person that was just doing something else. Okay, and so they could have maintained a history, or I'll show you a different architecture called REST where you don't have to maintain a history, but that's how you get from one page to another without having to log in. So they can track, they can attach that first line to the third line. They can say, okay, these 2 lines, these 2 requests, they came from the same browser, therefore the same user. Okay, so that's how they tie them together is with cookies. Then later what might happen is Alice might log in, right? And then once again, her browser's still sending this cookie. And then Google's like, hey, wait a minute, now I know who this person is, right? I just got this cookie and they just logged in and they're Alice, right? I checked their password against it. And so now I have two cookies for Alice. I have one from when she was logged in before, and then like maybe on a different device, and now I have this other one. And so then I can combine those two histories together, and whatever information I'm storing about the first Alice, I know that this is actually the second person, okay? So websites can like store information about you before you even log in. And then when you log in, they're like, okay, this person who was anonymous up to now, I now know who they are, and now I know, like, it's not just like every future action I'm going to log, I can log all their past actions as well. Okay, questions about this? How this works? All right. Okay, now do you have to accept every cookie that you're given? Okay, and so the answer is no, you don't have to. So there's different things that may or may not happen. So one thing you can do is you could disable all cookies. So browsers have that capability, even without an extension like the ones that you looked at for assignment 2. And in that case, what will happen is the server will still try and send them. So they'll send the message, they'll send the set cookie, but then your browser will just ignore it. Okay, it just won't add anything to the cookie jar. It's always empty, and yeah. You can also block third-party cookies. I don't know why this line got cut off, but a lot of browsers will have a different setting for blocking third-party cookies. A third-party cookie is basically like you're going to Google and they're trying to set a cookie for some other website that's not the website that you're visiting. So I'll show you like matching the website you're visiting with what's in the cookie. You'll see the format of that, and you'll see exactly what third-party cookie is later. But that's a more conservative setting, is that you just block third-party cookies, but you allow first-party cookies. Now, what happens if you actually block all cookies? Then you go to Google, you go to Gmail, you log in, and then you click that first message. What's going to happen if you have all your cookies turned off? Yeah, you'll have to log in again. It'll be like, I don't know who you are or whatever. Like, you won't be able to do that, okay? So a lot of the web breaks, right? So that's why you don't just go and turn off all cookies. You would have a hard time navigating the web if you did that, okay? And so, yeah, so we look for some middle ground positions like disabling third-party cookies. At any point, you can clear your cookies. So you can go into your settings in your browser and clear all cookies, and that will just empty your cookie jar. So now there's no more cookies, so that when you send those requests out, your browser just doesn't add anything, okay? Then servers will start setting cookies again, and so you'll quickly like pick up new cookies, but it will clear them. And what happens if you're like, you go to Google and you're like, keep me logged in, you clear all your cookies and you go back to Google, then you're not going to be logged in, right? So if you ever clear all your cookies, then you're going to get logged out of every website that you're on. The fact that you want the English version instead of French, it's going to forget all that. Like basically, it's going to be like you've never gone to the websites before. So all that configuration is going to disappear with the cookies when you empty them. So people are also hesitant to even empty their cookies, because then they have to go in every website, they have to log in again, and it's kind of a pain. Another thing you can do is you can say clear on close. So every time you close your browser, then it clears out your cookies. Okay, so they stay there until you close it. Instead of manually clearing them, you close your browser and clear it. Or you can do it manually. Another thing you can do is if you want to sort of temporarily clear your cookies, but you don't want to log out of everything, you can use private browsing mode. Okay, so this is actually exactly what private browsing mode is. It gives you like a fresh identity, all your cookies are cleared and everything like that, but only in that window. Okay, you go back to your normal web, then all your cookies are there again. Okay, so if you want to like, sometimes if you're like trying to debug something or something's not working and you think there's some issue with the cookies or whatever, you might try private browsing mode and then try and access it through it. But you don't have to actually clear all your cookies, so it's not going to log you out of every website. The other way that cookies go away, client side, is that they do have an expiration date. Okay, so cookies will expire, but the expiration date is set by the server. So the server decides what it is, and then your browser will enforce it. Okay, and so they can pick a date and time, or they can also ask for it to be cleared on close. So those are the two basic options. Okay, another thing you can do is you can go beyond what your default browser will do. So this is the stuff you looked at in assignment 2, Privacy Badger and Ghostry. So what they're trying to do is to give you finer grain control. They're also like visualizing it and kind of making you aware of how much tracking's happening. They're trying to categorize things so that you know, oh, this is a tracking cookie. This one's just for English, French. Like it's maybe not, I don't really care about it as much from a privacy perspective. But anyway, so those browser extensions, they'll sit in the middle. Now browsers though have also they give you more control now. So like Safari, you can on a site, you have to like kind of go deep in the menus, but you can like, if you have a tab open with a website, then it will say, here's all those tabs you have open, and then you can go into that particular website, and then you can say, don't allow cookies for just this website. It won't impact any of the other ones. So anyway, so browsers are trying to give you finer grain control over cookies, but you can also use an extension or some app like that to also control it. Okay, now server side. Okay, so servers can also clear cookies, okay? But you don't know whether the server clears it or not, okay? So for example, let's say you log out, okay? If you log out, generally what will happen is, by log out, what I mean is like you're in Gmail, there's a sign out button and you press that sign out button, okay? What actually happens in terms of cookies? What's the behavior that happens? So when you come back to the website, now they're asking for your username password. Even though you have a session ID cookie, right? They're going to ask for it again, okay? So why is that happening? Is it that your browser, when you hit that sign out button, it deletes that cookie? So the answer is no, because the thing that you do in the website, your browser doesn't know. Like there's no hook. You can't like click a link and then have like a browser setting change, okay? So it's not clearing your browser client side, okay? So what's happening is it has to be happening server side. Okay, so what the server will do is, you could think that they just delete it. So that would obviously have the effect that you would want. The other thing though is that if they just delete it, then when you come back again, they don't even know that it's you. So they can't track you, right? So usually what they would do is they would just mark it as like expired. Like here's a session ID. You'll come back with the same session ID. So they'll be like, I know it's you, but I'm going to pretend I don't know it's you. And then I'll ask you to log in again. And then when you log in again, then I'll mark that session ID again as like, okay, this one's okay now to keep them logged in. Or maybe I sign you a new one. Probably you would sign a new one because one reason people might sign out is that they're concerned that their cookie was lost. But yeah, but you don't know whether the server actually deletes it or not, okay? You just know the behavior that you see from the website as a result of it. Same thing if you uncheck the keep me logged in. So like when you're signing in, sometimes it's like keep me logged in or not. So if you don't check it, then the server will basically at a certain point, it will stop accepting that session ID. So if definitely if you hit the sign out button, then it will not accept it. But let's say that you're using your inbox, but you forget to sign out. So you just close the browser, you go away for an hour. Then the server might say, okay, I haven't seen this cookie for an hour. They said they didn't want to be kept logged in, so I'm going to make them log in again when I see it there. So I don't know how the semantics works on the server, but that's basically, at a certain point, it will time out that session. Okay, so what do cookies actually look like? So this is a website that I went to. This is TSN, and it's a pretty dirty website in terms of all the stuff that it does. So that's why I chose it. I actually could fire it up. So you can see this. I'll just show you how to do it so that you know how to do it for yourself if you want to play around. I'm always hesitant to do this because I don't want to like flash my. Now you know that you can steal sessions through cookies, right? So if I clicked on Google and then I have a video on YouTube, right, with my session ID, someone could actually conceivably log in as me. So I try and be careful doing this because I'm actually logged in. I should actually open private browsing mode and do this, but then none of the cookies will have any values. But anyways, I don't care. You can try and hijack my TSN session if you want. So if you go to storage, and then there'll be a thing called cookies. And so you can see these are all the websites that are trying, or sorry, these are all the resources that TSN is loading. So TSN is here, but it might be pulling an image off a different domain, and it might be running some JavaScript from another domain and all of that type of stuff. So if you want to see that at a network level, you can go back to sources. No, network. Here, so you can see like what exactly it's pulling from every domain. So like adservice.google.com is one of the things, and they're running this interrogator.js JavaScript, okay, or whatever, okay. So anyway, like I said, this is a pretty dirty website. Like it's running a lot of stuff from everywhere. And then you can see there's a bunch of cookies here, okay. So then if I click on TSN, you can see there's different cookies. They have different names. You can try and the server chooses the name, so you don't know what they mean, okay? But if you see SID, that means session ID, or UID means user ID. So you usually see things like that. And then sometimes you can sort of figure out, like, based on what it's named, what it's actually for. Sometimes they have some like random machine readable name and machine readable value, and you don't know why they're using that particular cookie, okay? So like I said, it's a name value pair or key value pair. They call it name value in inspect element. And so this is the name of it. So like UTSID. So that'd be like some user ID. And then this is the actual user ID value that they gave to me. Okay. So I'll go through these fields sort of one by one and show you what's there. Okay, so the list here is, these are all the domains that TSN is weaving together in order to display that website to you. And sometimes if you hang around on the website, like more and more load, because there's like ads and stuff that load in the background and things like that. Okay, so the first field of the cookie is the value or the name. And so this is what the server chooses. Okay, so they choose, so that whole column is the name that's given. And then these are the values. So some of the values are human readable, like null, or you can see UID. The second one on the screen is UID equals 00057. That's sort of like meant to be read by a human. One looks like JSON, like way down at the bottom, there's a success : true. So sometimes they're machine readable. Sometimes they just look like binary data, so you can't really make sense of them. If you decoded them, like base64 decoded them or something, you might see that there's something there. But anyways, it's up to the server how it implements it, like what these cookies are for, and what the values and things are that are being assigned. Okay, so we got to this website by going to exactly www.tsn.ca. Okay, that's the website we went to. Okay. And then these are the cookies that were set by that website. And the domain here says basically, when should that cookie go back? When should I send that cookie back? So let's say I'm not on www.tsn.ca. I go to images.tsn.ca. Should the cookies be sent or not? Okay. And so it's up, you can choose. When you set a cookie, you can basically choose when you want it sent back. And some choices there's some things you're allowed to do and some things you're not allowed to do, okay? And we'll go through them. So your browser might reject it. It might say that's against the rules. But anyways, everything that shows up here in this file was in the rules, within the rules. But you can see like there's at least 3 different kinds of things. So one is they'll do .tsn.ca. And so that will be a cookie that will get sent to any subdomain. So if it matches images.tsn.ca, scripts.tsn.ca, it will go along with that. Since we were on www.tsn.ca, you can set it to any subdomain of that. So this one's kind of weird. It's probably a programming mistake, but if you had images.www.tsn.ca, then this cookie would go along for the ride for that. So yeah, if we were just at tsn.ca, then it would make sense to have subdomains because it would include www and things like that. Okay, and then if there's no dot in front, like the last one is www.tsn.ca, it will only get sent to that exact domain. Okay, so if it's images.tsn.ca, it won't go. If it's images.www.tsn.ca, it won't go. And I have some slides coming up with all the different permutations of these rules. But anyways, that's basically, so the cookie will say, this is when I want you to send me back. And then you can also restrict it to a path. So you might say, only send it to www.tsn.ca/images/this. Paths basically aren't used. Almost no one uses them, but you could scope a cookie so that it would actually only go to an exact website or a folder of websites as opposed to just doing it by domain. Okay, the next thing is an expiration date. So the cookies won't last forever. So your browser will eventually, basically what will happen is you'll go back to a website, your browser will go through your cookie jar, and then it will say, when it's about to send the cookie because it matches the domain, it will check the expiration date, and then if it's past the expiration date, then it just won't send it. Okay, and this is based on your clock in your browser as well. So sometimes, like if your battery dies, or like there's sometimes like weird things that might have your system clock be like really wrong. If that type of thing happens to you, then you might go to websites and it won't log you in. Okay, and that's why. It's because your browser's like, oh, these things are expired, or yeah, usually the date would go back instead of forward. But anyways, okay. So yeah, so you can see a lot of them live. I don't know if there's a maximum that you're allowed to set, but anyways, I see one that's 2025 before it expires, and then some of them are marked session. So the ones that are marked session, your browser will get rid of. It won't actually go in and delete them, but anyways, if it ever tries to send it again, it will notice that it was from the last time, and then it won't send it. So session is the one that will delete upon close. So when you close your browser, it will delete. Then you can get into the semantics of what does it mean to close your browser, right? Like especially on Apple, like does that mean you quit? Or like if I close it and it shrinks down but it doesn't quit, like is that closing it? And so like, anyways, that's a whole discussion in and of itself. Cookies have sizes. I mean, the size is basically a couple bytes just for all the stuff that you need, and then mainly like how long's the name and how long's the value. So you can't see the values in this slide, but so your smallest bytes, like this one's just, it's 4 bytes. That's just because like the name of it's PVV and the value is 1, so that's small. So that's all that means. And then the biggest one is 490 bytes, and it's 490 bytes because the value here is like a really long thing. So you can see like there's a lot of data there. So that's basically, the size is just how big the value is, the name and the value combined. Okay, and then you have some flags. Okay, so this is where the security part comes in. So you have 2 flags that are used. One's called secure, and one's called HTTP only. Does anyone want to guess what these mean? I mean, you can probably figure it out. But. Okay, so secure is exactly that. So secure says you're going back to www.tsn.ca. This cookie matches it, but I'm going to http.www.tsn.ca. If it's marked secure, then your browser will not put it in. Okay, so it says basically only if the connection's over HTTPS, then you should throw the thing in. Okay, what about HTTP only? Okay. So first off, the wrong thing you might think is this sounds kind of like the opposite, like it's HTTP as opposed to HTTPS, but it actually has nothing to do with it. So the naming's kind of confusing. It has to do with whether the request is being made with a traditional HTTP request, like you type the address in and press enter, or it's JavaScript that opened it up. Okay, if JavaScript requests it, then it goes over XML HTTP request. And so if it's marked HTTP only, whether it's over HTTP or HTTPS, it will send the cookie, okay, depending on whether the secure flag's marked. But if JavaScript makes the request and this flag is set, then it won't send the cookie, okay? It will only send it through, like you click on a link or you load something the traditional way, okay? So yeah, and we'll see later when we talk about things like cross-site request forgeries and cross-site scripting, why you would want to do this. But anyways, you can see none of these cookies happen to have that thing set. If you went to Google instead, they're more sophisticated, and you'll see like a mix of the secure flag set and the HTTP only flag set. Okay, any questions about this?
Sorry.
Yeah. So all I'm saying for now is it won't get sent when JavaScript opens the connection. But there is a connection to cross-site scripting that you'll see later. Yeah. Yeah. Okay. Yeah, so how do you know your session ID is actually long and random enough? So this is under the server's control. So you as a user have no control over that. If a server gives you a session ID that's not long enough, or if their random number generator is broken and they're giving 5 users the same one, you can't do anything about it. It's just like, yeah, you might log in and you might be logged in as a different user or something like that by accident. So it's completely server controlled. There's no enforcement of it. Your browser doesn't know the difference between a cookie that's used as a session ID versus one that's used, whether it's English or French or whatever. So it just cookies are cookies kind of thing. Yeah. So you're at the mercy of the browser. Now, when you use like a web framework like WordPress or like whatever you're using, I don't know what people currently use, that software will come with the ability to generate cookies, and it will do it in a secure way and all that type of stuff. So if you're doing some turnkey server thing, it's going to be in that software and taken care of for you. If you're doing it custom, then you'd have to be careful about session IDs, that they can't be guessed and that you have good randomness and they're long enough. Yeah.
But from the server side, is there any standard policy, like certain session ID was generated? Maybe now it's a good time to again start reusing it.
Yeah, they won't ever reuse them. So they'll make them long enough that they remember it's exponential growth, right? So you can have a thing, like say it's 64-bit or base 64, and let's say it's, I don't know, 12 characters long. That's like more than the grains of sand on the earth, like kind of thing. Like it's just an enormous number. So if you choose it at random, like the chances that they collide is basically negligible. Yeah. And then sometimes they might use cryptography as well. So they might have a key, they might generate a value, and they might apply what's called a MAC to it. So your cookie will be a MAC of your username under the key or whatever. Maybe with a counter so that they can change it every time. So sometimes there's a cryptographic structure to it as well. Yeah. And then that makes it easier because when the cookie comes back, they don't actually have to store. So a different way you could do is encrypt it as well. So that then you just actually have to store the key. So when the cookie comes, you just decrypt it and it tells you what the username is. So you don't have to have this big file of all the users and the cookies you gave them. The cookie itself tells you what all that you need to know. And because there's a key, I can't change that information or make it up. Yeah, so you need an authenticated encryption scheme, but you could do it that way as well. Okay, now what happens is, let's say that, so I went to www.tsn.ca. I'll just show you. And you can see that there's a bunch of other websites here, okay? And they all want to have cookies and things like that. But if I click on them, you'll see that there's actually no cookies for any of them, okay? So why is that? Why is TSN have cookies, but none of these other ones have cookies? So the answer is, this is my browser setting, okay? So I have a setting that's just the default with Safari, and it says stop third-party tracking, okay? Now, one thing I want to emphasize is that these things here, a cookie that would show up here, it's not technically a third-party cookie. So this term is like sometimes confused. So third-party cookie is when you get a cookie from one website like tsn.ca, and it says, and it puts, like, say I get a cookie, it comes from tsn.ca, but in the domain it says cbc.ca. Okay, that's a third-party cookie because the domain doesn't match the website that I'm visiting. But all of these things are websites that I actually went to and visited. Okay, so I went, like when I download TSN, it's opening a connection to Google asking for a JavaScript. So it's going to Google, and Google themselves, with their response, they're setting the cookie. Okay, so it's not a third-party cookie. It's just that I opened a connection to that website, but it's a third-party tracking because they're involved in this particular website. So you'll see these differences made a little more clearer. But anyway, so I have this setting that says prevent cross-site tracking, and because that's turned on, it's basically only letting the domain that I'm visiting set cookies. So any other resources that I load, my browser will ignore all the cookies that they want. Okay. Then what I can do is I can go and I can turn that off. And then if I go back, then I'll go through them, and you'll see that there's lots of cookies for all of these things. And even when you turn it off, you'll see that it's like once the servers realize that they're able to set cookies, like they'll set a cookie and then they'll get the cookie back so they know that it worked. Then they'll open up even more connections to other websites. So like you can see like even the number of sites then like exploded that wanted to set cookies once I turned that setting off. And so yeah, so then I would go through them all, and I'm not going to do it live because it's just a pain to turn on and off, and I don't want to show all my cookies on a YouTube video. But anyways, it's what you would see is if you clicked on each of these domains, you would see that they all have like 4 or 5, or sometimes 10 or 20 cookies set. Okay, questions so far? Okay. So then I'll just go through the semantics. I already said it sort of in words, but I'll show you explicitly. When you are at www.tsn.ca and it wants to set a cookie domain to be .tsn.ca, we said that's allowed. Okay, so what is allowed and what's not allowed? What are the main combinations? Okay, so let's assume that we're at a website, encs.concordia.ca, and this will always be the website that's setting the cookie, okay? So a response from that website has set cookie in the header, okay? But the cookie itself is allowed to set a domain, okay? So domain is a field inside the cookie, and what's put in the domain of the cookie doesn't have to be encs.concordia.ca. It could be something else, okay? And so sometimes I'll say that's okay, and sometimes I'm going to say, no, that's not okay. Okay? All right, so the simplest case is that if I go to encs.concordia.ca, I get a cookie, and the cookie's domain is also encs.concordia.ca. That's allowed. We call that an exact match. Okay? And if I go back to encs.concordia.ca, that cookie will go along for the ride. Okay? But if I go to anything else, so it could be a different subdomain like images.concordia.ca. It could be a subdomain like images.encs.concordia.ca. It could be a super domain like concordia.ca, or it could be like a completely unrelated website like canada.ca. Then that cookie is not going. Okay, so if I'm going back to that exact domain, then the cookie goes, and if anything about it is different, then it's not going to go. Okay, so this is the easiest setting. Now, a lot of times you do want to share cookies, right? Like say I'm logged into hub.concordia.ca, and then I go over to moodle.concordia.ca. Should I have to log in again? No, right? But I have a session ID, but I'd have to pass that cookie somehow between those two subdomains. Okay, so this is not the behavior you often want. If your website's really simple and you're not using a lot of subdomains and things like that, you might use this. But what you'll see is Stack Overflow in places like that, like just full of people like, I can't get my cookies to work. And then they'll be like, oh, just make it a wildcard cookie. Like make it like So it shares it with everything, basically, and that's the solution. But that's bad for security as well, right? Yeah, for developers. Yeah, exactly. Yeah, not for users. Yeah. Okay, so a wildcard would be you could put a dot in front. So this is just, so I got the cookie from encs.concordia.ca. Inside the cookie, the domain is set to .encs.concordia.ca. And that says either an exact match or any subdomain. Okay? So encs.concordia.ca is fine. This is a typo, actually. I'll fix this because I don't want people to do it wrong on the exam. So this should actually, it should say images.encs.concordia.ca. Actually, going to images.concordia.ca is not allowed. Let me just actually fix this here.
In child domain, it can be allowed.
Sorry, say again.
Child domain of the domain that has been supposed to create a cookie, child domain can be allowed.
Exactly. Yeah. So subdomain or child is another way of saying the same thing. Yeah. Okay. So so this is a subdomain of encs.concordia.ca, so it will go along for the ride. If you go up a subdomain, it won't. If you go to a companion, like a sibling, like a sibling domain, then it wouldn't as well. Okay, so the differences between these two is this one has the ENCS inside of it. Okay, so this is a subdomain of this, but this is a sibling domain of it. Then it's not going to work. And if you go to an unrelated site, okay. Now, what if you do want to pass a cookie you're going to encs.concordia and you do want to pass it over to images? Okay, can you do it? And so the answer is yes, you can. So you can go up a domain, but you can only set it as a wildcard. Okay, so you can't set it for another specific sibling domain, but you could set it for the super domain of you and all of its subdomains. Okay, so this would be an exact match and a subdomain of concordia.ca. Okay, so encs.concordia.ca obviously matches still. Images.concordia.ca now does match because you moved up to .concordia.ca, and then .concordia.ca would also match. Yeah. So you can always go down. So you mean like images.encs.concordia? Yeah. So the star is literally a wildcard. So anything behind it is okay. Good question. So let's just hang on to that. Okay, but Canada.ca is not going to match because it doesn't match. Okay. I think my slides got messed up. Sorry. Okay, sorry, I have the same slide twice. I don't know why. But anyways, I think I changed the text. When I was copying and pasting it, I did it wrong. But this is exactly the same as the previous slide. I just changed the description to super domain and any subdomain of it, which is a better description of it. Let me, while I'm here, just delete that. Okay, so I'm at encs.ca, concordia.ca. I can go up to a super domain, which is concordia.ca. Now the question is, could I go up another super domain, and could I have a wildcard certificate for all of .ca? And the answer is no, okay? And it's not against the policy, technically there's nothing wrong with it. It's just that browsers step in and say, it's stupid, you shouldn't do that, so we're not gonna let you do it. Okay, so you're not allowed to set a wildcard for any top level domain at all, and it's just a browser decision not to do that. And doing that would be super dangerous as well. And you know that developers are going to do it because then it's going to work on all their websites, but they don't realize that it's being shared with every other website on. Yeah, exactly. Yeah, so there'd be too many matches. Okay, and then the other thing is, let's say you're at encs.concordia.ca can it set a cookie for Canada.ca? Okay, so this is a third-party cookie. That's what it means. And the answer is that it generally isn't allowed. I don't know of any browser that by default lets you do that. It might have been allowed like a long time ago, but now it's basically like no browser. I don't even think when you unclick all the like settings and things like that, it will let you do this. So it's more or less not allowed. Sorry, say what? No, it's just the browsers themselves decide. So the people like at Google that make Chrome, they spend a lot of time thinking about these issues, and sometimes they make the change, they'll announce it. It's not exactly for cookies. I don't know where like any decision they make that pertains to HTTPS, there is a kind of regulatory body, but it's a self-volunteer thing. It's called the CA/B form, or CA/browser form, CAB form. And so it's like all the major browsers and all the major CAs, they come together and they'll set policies, kind of. Or Google will just say, we're doing this, we're turning it on a year from now. You know, if you're warned, right? We're going to turn it on, and if it breaks your website, you have a year to fix it. So they'll sometimes do that type of thing. But there's no government regulation or anything like that. Governments they actually do step in sometimes. So in the video, it's kind of older, but there used to be this do not track thing. And it's kind of like buried in with all the different things. But the do not track is something that's government policy. So that was legislation that was passed by the government that said websites need to have this option. Browsers should have this like header that they can send that says do not track. And this is how a website should respond to it. So yeah, I take it back. It actually could be government type of thing. But generally, it's the browser manufacturers that decide these things. And then websites go along with it. And then sometimes they make changes because people push for changes.
What's the relation between the cookie and the certificate? For example, if a cookie, the setup of a cookie says that it allows wildcard, but your certificate is not a wildcard. Is there any...
Yeah, so there's no connection at all. So the cookie has to do with, like, well, okay, both of them are like, when should I use this in the future, right? And so they're the same policy. Like a wildcard means the same thing in both a certificate and a cookie, but certificates and cookies themselves are doing different things, we'll say, yeah? So your browser will look at a wildcard and say, this domain matches it, so I'm going to send this cookie. And then if you get a certificate and it matches because of the wildcard in the certificate, then it will say, then this certificate's fine. Like it works for the website that I'm visiting. So they're both about pattern matching. They're both about trying to match the domain you're visiting with the domain of some other object, whether it's a cookie or a certificate. But then one's for HTTPS and the other one's for cookies. That's all. Okay. Then the last thing that I mentioned that's not used very often is you can also have this path domain. So let's say I'm going to encs.ca. I could set the domain to also be encs.ca, so an exact match. And then I could further say that the path for this cookie is --Clark, okay? Then it will only send the cookie if I'm going to websites at that exact, like encs.concordia.ca/Clark. Or any like subfolder or subdirectory of that, okay? So if I go to Manon's website, it's at a different path. It's at the same server, but it's at a different path, so it's not going to send that cookie along, okay? So you can set the path if you want. I've never seen it. Like I go into inspect element every now and then, and I've never actually seen the path set, but technically it's there, and you could use it if you wanted to. Okay. Let's take a break, and then we'll keep going. So come back at 7:15. All right, so this is what the browser policy looks like, sort of in a slide. So you ask a website for something, it sends back a response. Inside the response, you open it up, and it starts asking you to load images and videos and JavaScript from all over the web, so that's fine. And then what your browser is basically doing is it goes through every single request one by one, it pulls it in, it looks through the whole cookie jar, and it sees is there a match or not for it. And so some of these requests will match something that's in the cookie jar, and so it will prepend it and it will go out. And then other ones you might not have a cookie for it, and so the request will just go with no cookie. Okay, so it tries to match it based on the destination. So where is it that you're going, and what's in the cookie, like what's the domain that's set in the cookie itself. It will do a quick check, make sure that it's not expired, and then it will do a quick check that if any of the settings are set, like don't send it through JavaScript requests, or don't send it over HTTP, it will check those flags as well, okay? And if everything's good, then it will put the cookie in the request, and then it will send it off to the server itself. Okay, so going back to that video that we watched, you know, I said that one of the problems with cookies is that you can use it for tracking users. Obviously, within a domain, you can track them. So Google, they give you a cookie, and if what you're searching for and what images you're looking for and what emails you're reading, they know all of that stuff. That's sort of obvious because it's all on Google, right? But if I go to Lululemon and I look at a shirt, and then I go to CBC and they show me an advertisement for that exact shirt, right? Then like how's that possible even, okay? And so the answer is that you can use cookies for tracking people even across websites under certain conditions. So let's say I go to Lululemon, I'm like, okay, give me a website. Then I look at this shirt, and then Lululemon might have a relationship with an ad agency, okay? So what they can do then is they can send requests to load some JavaScript or whatever, basically ping the server and bring it down. And when they send that request, it's actually my browser that's sending it, okay? But they constructed the index.html that made that request. They could also just pass on, this is the shirt that I was looking at, okay? So maybe it has an ID number, and they'll throw that in, and then so then when the agency gets it, they know who I am based on my cookie. They don't know my name necessarily, and they know what item I'm looking at and things like that, okay? So that's fine. So then, and then they set a cookie also. So they're like, okay, I'm going to call this user 55, and I know that user 55 was looking at this shirt on Lululemon. Okay. Okay, great. Then I go over to CBC, and I send a request, and then if CBC outsources its ad to the same agency, okay, so this agile1.com, they have to be the same, or they have to have a business relationship between them, okay? If it does, then what will happen is I'll request my browser. It will basically, CBC will say, okay, here's a box, and I want an advertisement put in that box. The people I'm paying or paying me, I should say, in order to run ads on my site, right? It's revenue for CBC. It happens to be this ad agency, agile1.com, and so that's fine. We'll just I'll have some JavaScript, and they'll give me an ad, okay? Now what happens is your browser's like, hey, wait a minute, I know agile1.com. I actually have a cookie for them, right? They gave me a cookie that said my UID is 55. So when I send this request, I need to put that cookie in, okay? So I put that cookie in, and now Agile1 is like, okay, I know who you are, right? You were the person that was just going to lululemon.com. I even know the exact shirt that you were looking at because it was a parameter that was passed. So the exact shirt would have to be, like Lululemon would have to decide that they were going to give that level of information to their ad agency, right? So it doesn't necessarily happen by default. They might know that you're the same person, but they might not know what you were looking at, because technically Lululemon's a completely different domain than Agile1. But in this case, in this fictitious example, that item gets passed as well. So then they're like, okay, no problem. We'll show you an ad. We'll show you an ad for item 9483 because we think that that's something that you're looking for. Okay, and I've had it happen where you go to a car website, and then the next time you're on like some news website, it's like that car brand is like showing up, or like clothing stores and things, and it literally happens where they'll show you the exact same product. Like it's not just it's the same store, but it's like that's the exact product that you were looking for. Okay, so we call this third-party tracking, and it basically relies on websites sharing some sort of person in common with all the websites, okay? So who is agile1.com in practice? Often it's Google, okay? So Google plays that role. Now, why would websites add Google to it? So I actually have Google on my website because it gives me all sorts of analytic information. So if people find my website because they search a certain search term on Google, that's the deal that you make. So you say, okay, Google, I'm going to put your tracking stuff on my website. I'm not getting paid for it, but I get data. Right now I know who my users are and what they were searching for and things like that. But then now Google can track like what part of my website they were looking at, and then they go over to another website that also has the same kind of relationship. Then they go to another website that has ads that are provided by Google, and then Google's like, okay, I know what ads to show you. Okay, so I forget the statistics in the video, but like something like 3/4 of websites in the Alexa top 1,000 or 1 million sites have Google on them, and a whole bunch had Facebook. I think that maybe has changed because Facebook has sort of suffered from a privacy perspective, but Google is very, very, like lots and lots of websites have Google stuff loading. You saw on TSN there were Google resources that were loading. Okay, and then in Safari, when I said turn off third-party tracking, that's why even though I went to TSN and it started loading stuff from Google, those cookies weren't getting sent. Okay, my browser wasn't sending them because I had disabled third-party tracking. And with Ghostery and things like that, that's also what it tries to do. It tries to let you turn off like cookies that are used for tracking purposes as well. So this is sort of changing how much we're able to get tracked. Okay, any questions about how this works? Okay, just one last thing to talk about today. Are cross-site requests, okay? So this is another way that cookies are used. So a cross-site request it's almost the exact same thing that we saw. Let's say I go to cbc.ca, and CBC wants to have like a little box for Facebook, and it might have a like button, and so if I click that like button on CBC's website, then it will like the article, but it's actually going to like it on my Facebook profile. And if you went to my Facebook profile, you would see that I liked this CBC article, okay? But they want it to be a very seamless interaction, so I don't have to like copy the bookmark, like the URL over to Facebook and like it on the website or anything like that. I'm already on CBC, right? I click the like button, and then you might even see something like, I don't know, 7 of your friends like this article, okay? And so this is on the CBC website. Okay. Now, next class, we're going to talk about the same origin policy. So one question you might think about is, does CBC know that 7 of my Facebook friends like this article or not? Because I'm on their website and it's showing that information is embedded on the website itself. And the website says CBC, that's the domain, right? So are they able to see that information or not? Okay, and I'll answer that question next week. But the main point with cookies is when I request that like button, the JavaScript from Facebook, my cookie goes along with it, okay? So Facebook does know who I am, okay? So if I hit that like button, that's going to trigger an action that's with this JavaScript, and it's attached to a cookie that my browser is throwing in, okay? So Facebook knows it's me if I'm logged into Facebook, okay? And when it shows me that 7 of my friends like this article, that's real because Facebook does know who I am because my cookie's getting sent when I go to Facebook, okay? So I'll request the like button because CBC tells me to, and if I'm logged into Facebook, then my cookie will automatically get put in by the browser, and then Facebook will say, hey, I know who that is, that's Alice, and now when I send the like button, I can embed information from Alice's profile, like personal information, or like I can personalize that. It's not just a generic button anymore. This is Alice's stuff, okay? And I know that I'm not sending this to the wrong person based on their cookie, okay? So this is also how cookies are used. It's one of the big purposes. So we call this a cross-site request. Cross because I'm actually on CBC's website. I'm not going to Facebook, and yet I'm making a request to Facebook. It's a different website, and it's logging me in sort of automatically or like because I'm logged in, it automatically knows who I am, and then it's able to serve personalized content. Okay, now another thing that's just an aside, has nothing to do with cookies, but I'm going to put two things together. So I'm going to put the cross-site requests together with this idea, and then I'll show you an attack. Let me just show you, it's maybe a little easier to do this. So the problem is if I go to Google, Safari's smart enough that it like puts the search terms up here. It doesn't show me URLs. So this is like the one time in my life that I use Bing instead. All right, so I go to Bing, whatever. I want to search. This is really laggy. All right, so whatever. I search for Toronto FC, okay? And so it shows me a bunch of results, all right? Now, let's say I want to click this next button. I want to see the next page of responses, okay? So it's going to show me page 2 of it. Now, this is just like that kind of Gmail example. I was on this page, and I click this next button, and it's now showing me results 10 to 20 instead of 1 to 10, okay? How does it know that I'm the same person, and how does it know that now, like I was just looking at results 1 to 10, and now I want to look at results 10 to 20, okay? And so one answer is it could keep track of it. Maybe it uses cookies or whatever, so it knows who I am, and then it has a database, and it's like, okay, I sent them the first page of results. They clicked on the next button, and now I'm going to look up and say, okay, what page were they on? Oh, they were on the first result page, so now I'm going to show them the second result page, okay? So it can just sort of keep track of where I am. The problem for the website is that's a lot of information that it needs to keep track of, okay? So it needs to store all that information in memory, and it has millions of users and things like that, okay? So websites don't want to do it. So what they'll do instead is they'll take that information and they'll embed it in the URL itself, okay? So if you look at the URL, you'll see that the search query is here. And then somewhere in here will be like what page you're on, and like there's a bunch of other stuff. CVID we'll talk about later. You know, first equals 7. I don't know, but like somewhere in all these parameters is all of that information. Okay, and more importantly is when I downloaded this website, it's giving me the HTML. Okay, so when I click on this arrow, I'm going to another URL. And that URL is embedded in the page that I'm looking at. So what it did is it said, okay, I know you're looking at the second page of results, so I'm going to hook this URL up to the third page of results, and I'm going to embed it in the URL itself, okay? And the key idea here is now I can completely forget about you. Okay, I gave you a website, and if you want the third page of results, the third page of results is inside this URL that's already in the website that you're holding in your hand. I'm holding this website. It has a bunch of links to other things, and all of that information is embedded in the URL. So now Bing doesn't have to remember anything. And actually, when I click this link, it's not that it takes me to the next page of results. What it actually does is it reads the URL and says, this is a person that's looking for Toronto FC, the third page of results. It will actually re-execute that search, right? And then it will go to the third page of results, and then it will send it back to me. So it doesn't know who I am. If I send this URL to you, you can just click on it, and it will take you to as if you searched Toronto FC and you're on the third page of results, okay? So everything's sort of embedded in the URL. It makes it, we call it stateless because the server doesn't have to remember anything about where you were. It doesn't have to keep track of you as you go through the website. Everything's in the URL itself, okay? All right, so that's fine. So this is called RESTful architecture. Okay, questions about it? Yeah. Yeah.
Still, Facebook will know that you are visiting CBC, and CBC will know.
Yeah. So.
Even though you are visible.
Yeah, if I have the privacy enabled, let's phrase it that way. So if I have the stronger privacy version, then it will say you're on cbc.ca. I see you're opening a connection to facebook.com. I do have a cookie for facebook.com, but it won't drop it in. So it's just like when I looked at all the other URLs and the cookies were empty for all of them, that's the same thing that applies here. Yeah, so this wouldn't work in that setting. Okay, now the problem is with cross-site requests and the fact that we have this RESTful architecture, we can actually put the two of them together and make an attack. Okay, so the attack is called cross-site request forgery. So cross-site requests are not bad. So sometimes because cross-site request forgery is like kind of famous as an attack, people, they hear cross-site requests and they think bad, okay? Cross-site requests are good, okay? They give you functionality, they give you Facebook like buttons and Twitter subscribe buttons and things like that on your website. So there's nothing wrong with a cross-site request, okay? But a forgery is when basically you're making that cross-site request and you don't actually know what's happening. Like your browser's doing it because that's how it's programmed. It's how the cookie policy works. And it doesn't, and you as a user don't know actually what's happening, okay? And then because websites are using RESTful architectures, they also don't know that, hey, this is a user that's like they logged into their banking account, then they looked at their checking account, now they want to send money from account 1 to account 2. They just see this URL that says send money from account 1 to account 2, and they don't have any previous state about the user. So even if that comes out of the blue, and it's just like this URL pops up that says to do it, they'll just say, well, if the cookie's there, it's the user and they want this done, so that's fine, I'll go ahead and do it, okay? So what happens is you, in the attack, basically you have to lure someone to a bad site, okay? So that's the first step. So it's not, so either you take over the site, somehow you poison it, or you do cross-site scripting, some other attacks that we'll talk about next class. But anyways, or it's just like a phishing email or something like that, but you get the user onto your bad site. That's fine. Then what you do is you just, you have to find a vulnerable service. So you might go to the bank.com and you might realize, okay, bank.com, it uses this RESTful architecture, and I can actually send money, like I can do a transaction just by putting it into the URL. Like that's an action that's possible on this website. Then all you have to do is when they load your page, is you just have to hit that URL, right? So it doesn't matter, you can say load it as an image even though it's not an image. Then when the image comes down, the browser will be like, this isn't an image, and it will have an error or something like that, but it doesn't matter, it's already too late. You basically just have to hit that URL, okay? And what the user's browser will do is it will say, okay, this URL, it's going out to bank.com. Do I have a cookie for bank.com? And it will say, yeah, the user's logged in, and they do have a cookie, it's user ID 55, so I'll just throw that along for the ride, okay? And so then this goes over to bank.com, and then from bank.com's perspective, this is exactly the same as if the user logged in and they went through their accounts and all that stuff, because I'm not tracking that information. At some point, they're going to hit that URL that says to transfer the money, and the only thing I care about is, you know, is it actually the user or not? And I make that decision based on whether the cookie's there or not. Okay, so I get this URL. It has the right cookie, right? Because the user put the cookie in. So the right cookie is there, and so then I'll just transfer the money. Okay, so this is called a cross-site request forgery because the user's not intending to do that. Okay, they're not intending to go to the bank and have that action take place. That was manufactured by the person that gave the website, the evil website. And they just make the user hit the URL. Because the cookie's copied in, then the bank just thinks, okay, this is the legitimate action. Okay, is that clear enough? And there's many variants of it, and you'll take a network security course if you haven't, and they'll probably show you 10 different ways of doing this and 10 different ways of doing cross-site scripting and things like that. But anyways, the reason I'm going over this in this course is more to think about it from a policy perspective, okay? So it's the way that we use cookies, it's the way that cookies are included and things like that. That's the underlying nature of this attack. If the policies were different, like say we didn't allow cross-site tracking, right? That could be a policy decision that Netscape made back in 1994. Then we would never have had cross-site forgeries. But we also wouldn't have Facebook like buttons, right? So that's the pro and con of it, okay? Now, how do you fix this? Right, so we know that like websites still use this RESTful stuff, right? And we've heard maybe about these vulnerabilities, and somehow websites go and they fix it. So there's got to be a way to, there is a way to fix it, right? So how would you fix it if that was your task?
Maybe have a token that the user needs to get before they can send the request.
Okay, so a token that you would.
So, for example, that would be set on the /account page.
Mhm.
Before sending the request to the account transfer.
Okay, so that's actually quite close to what the solution is. Not exactly it. But what would the token, when would you get the token, and where would you have it, and how would you make sure that you put it back in? I know you're thinking off the top of your head, so you might not know those answers. But
So get it from the bank.com website.
okay, so the bank.com sends you a token, and the first time you visit it or whatever, and then you have to keep passing that token back. Okay, now that sounds a lot like a cookie. A cookie is a token that you get from the bank that you keep passing back.
Yes, that's what I know.
Okay. So actually, it's not about one time. It's actually about where. See, the problem with this is that your browser's putting the cookie in for you, kind of thing. Okay. All right. And the cookie's going into the header. Okay. So that idea is actually exactly right. First off, let me dismiss a couple bad ideas. So you might do it based on refer, right? So you might say, well, the referrer for this was evil.com, right, to the bank. But if you do like JavaScript-based like requests, you can like obfuscate the refer. The refer is basically just not reliable. Let's put it that way. So that's one way that you could do it that doesn't really work. You could try and do IP tracking and things like that. Like, have I seen this user before? Are they just jumping into this one operation without doing a bunch of stuff before? But the evil.com could do, like, they could log you in and make you look at your account. Like, they could send 10 URLs that are kind of like the progressive steps that you would do leading up to the transaction itself. So that would look a lot like the real trace of a user going on the website and going through all of these. Okay, so the answer is, let's do what was suggested. Let's put a unique token in. We're going to put it in the URL, but we already have the user's cookie. Okay, so what we're going to do is we're actually just going to stick their cookie in the URL. Okay, so this sounds like kind of crazy, and it takes a while to sink in, like why exactly this works, but it does work. Okay, so okay, so basically, imagine this is the URL and it comes to the bank. So let's think of it from the bank's perspective. Okay, so the bank is going to get someone that hits this URL. It has the cookie value in it, and the request for this will also have the cookie. So the cookie is going to show up in two places. I should have drawn it out more like this line here, like with all the information. But basically, you're going to have the request with the cookie in the header, and we're also going to have the cookie in the URL, and we're going to have the cookie in our database of all the users that are logged in. So it's going to show up, from the bank's perspective, it will show up in three places. If I see it in all three places, then I'm going to accept that this is a valid transaction. Okay, so that's fine. That's the policy. Okay, now the question is, why can't the adversary do that? Okay, so the adversary has evil.com. Okay, so this account that the adversary controls, or actually I should phrase it differently. This URL, who is it that decides what this URL is? It's the adversary, right? The adversary embedded that in the index.html. Okay. So in order for the adversary to do this, they would have to have NUID equals 55 at the end of this URL. Okay? Does the adversary know the user's cookie? Okay. But does it know, let's say before this attack starts, so I send you an email, a phishing email, I'm hoping you click on the link, do I know your cookie? I don't, right? If I knew your cookie, what would I do? I wouldn't phish you, I would just log in already, right? Okay, so I don't know the cookie. So when you say, give me index.html, do I know your cookie at that point? No, because all I did was request it. Okay, so that's fine. But now I have to embed it at that point in here, so I don't know your cookie, okay? So there's no possible way that I can embed it, at least the first time. Now, the other question you might have is, okay, when the browser puts the cookie at the start of this request and sends it out, does evil.com see that? Right? Does it or not? Okay, so we have one yes. Anyone want to say no? Some people are saying no. Okay, so the question is, I request index.html from evil.com. I get index.html from evil.com. Index.html tells me, go to bank.com and request this URL from bank.com. Go to /account, blah, 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 right? And my browser says, hey, wait a minute, before you put that request out, I have a cookie for bank.com, so I'm going to drop that cookie in. So it drops the cookie in, then the request goes out, okay? Where does the request go? It goes to bank.com. Does it go to evil.com to forward to bank.com? No, it just goes directly to bank.com, okay? And the browser didn't put the cookie in until that request was already made. It's not like it's happening in the HTML of the page or in JavaScript or something like that. Like, this is like the package is ready to go and the browser's just throwing it on at the end, okay? So the answer is no, the evil.com does not see this cookie as it goes to bank.com. And if it's over HTTPS, even if it was in the middle, it couldn't intercept it, okay? So it has no way of knowing the cookie, okay? Then you might say, well, how does the attack work in the first place? How did evil.com get you to go to the bank when it doesn't know your cookie? And the answer is, well, the browser's putting it in for you, right? So that's why, like, the mental model is weird. Like, either you think everyone sees your cookie, then you know this attack is possible, right? Or you think no one sees the cookie, then you would think this attack is not possible, right? But it's sort of in the middle where it can't see it, yet the attack is possible. Okay, so this is why, like, this attack is weird, and people struggled with it for a long time. There were lots of subtle vulnerabilities in websites for 5 years, in all the major websites and things like that, because it is a hard mental model to sort of grasp. Okay, but anyways, yeah. So this approach works because basically the adversary doesn't know the cookie, so they can't put the cookie in this URL. Okay, and it works from the bank's perspective because it's very easy to check. You already have the cookie, it's already riding along with this, so you just take what's in the URL, you match it to the cookie that you got, and when they're the same, then you're like, okay, it passes that check. I know this isn't a forgery, okay? Then you have to check whether this is a real user and they're actually logged in and all that stuff, so then you can go over and check your user ID thing, okay? But anyway, so this is very simple, and if you go look at your URLs, you'll see like cookie value, cookie cval, like you'll see like parameters like this, which are your cookies that are stuck there. Sometimes they do like encryption on it. So I'm trying to keep this as simple as possible. So there's reasons why you would encrypt it. So if you actually inspected element and you looked at your cookie and then you looked at the cval that's in your URL, they might not look bit for bit the same. And that's usually because there's some encryption or something that's happening. But you can just ignore that encryption step. Okay, questions about this?
Sometimes when you go to the bank, they don't allow you to press the back button.
Right.
Is this because of this?
No. So it's not because of this attack. Usually, it's because they. It's actually probably because they're actually not using this architecture, this RESTful architecture. They're probably using something called POST. So what POST does is, if you want to send data to a website, you send it as what's called. It's just like a request, but instead of a request, it's a post. So you post and then you send a bunch of data and then it receives it. And if you hit the back button on a post, because that's a browser action, it's like going to a website, then you'll post it twice. And so that's the concern, is that like if you're doing some transaction, you might do it twice by accident. Yeah. And then there's also like race conditions that can happen. Like if they're doing a credit card check and then you kind of stop it and then it's like, did it go through or not? And the website thinks it didn't go through because you went back, but it actually did go through. So then it might try and get you to go through again because it didn't refresh the page. So yeah, it's more about like that kind of stuff. It's about like accidentally doing the same transaction twice, or the website is stale and it thinks the transaction didn't happen, but it actually happened, which is a fancier way of saying doing the same transaction twice. Yeah. Okay, other questions? Yeah. Okay, so this would be it would be, so how, what the website calls it, and if it uses the exact same cookie as their session ID, or like usually they have a bunch of session IDs, and like when you look at like the cookies that a website sets, they'll set like 20 different things. So it could be messy, but the high level is it should be treated the same way as a session ID. So it's a secret value. If I can steal this value, then I can put it in the URL, then I can trigger these actions. So I can hijack your session essentially by knowing this value. So whether it's the same as the session ID or it's a supplementary session ID, it needs to be treated as if it's a session ID. So it needs to be long, it needs to be random, it can't be guessed, it is a secret. If someone hijacks it, then you could get attacked. Yeah. Okay. All right, so summary of cookies. Yeah, okay, so this is good. Thanks for asking it, because I didn't actually explain it very well. So remember when you go to bank.com in the first place, like, so I only showed the flow of the attack, right? But I should have shown the flow of you just interacting with bank.com as if you're going there for the first time, okay? So what will happen is you'll go there the first time, and you'll send your cookie along, and it will ask you to log in or whatever, and it will log you in. It sends you back a website, and all the things that you might click on, like show me my checking account, show me my saving account, those are all URLs, okay? Now, because the website knows the cookie that it gave you, it's going to put that parameter in the URLs it's giving to you when you kind of come through the front door of the bank. Yeah, so that's how they get there, is that the bank is putting it there because they're giving you the website that has all these URLs. Yeah, and then they also don't have to track where you are on the website because all that also is embedded in the URL. Yeah. Okay, good. Yeah, maybe I'll maybe augment this slide for next year with the proper interaction so that you can see that. Okay. So first off, the referrals aren't you could try to solve this problem with referrals, and so some people do that, but anyway, this is considered the preferred approach, I would say. And then the second part I didn't quite catch.
Right. I said that it's not a good idea to put sensitive values in the query string, right? Because it could potentially leak depending on the configuration show up in the refer values on other websites.
Yeah.
So it would make sense that instead of making a request with the value on the query string, to put it on the header of this specific post, to put it on the body.
Yeah. Okay. So you may be right. There's a third solution though that is the one that's done in practice, which is actually the website will just encrypt it. So they'll still put it in the query string because it's more convenient for the website, but then they'll encrypt it because, like you say, yeah, it might get accidentally leaked through the refer, or you copy and paste a link, like whatever, you're on Google and you're like, here, check this out, and you don't know that you're giving someone your cookie because it's in the URL or that type of thing. Yeah. So usually it will just encrypt it. So the final step is it will decrypt it, and then it will do the matching between the two of them. Okay. Other questions or comments? Okay. So the summary basically of cookies are they're good and bad. So they're good because they keep you logged into websites. They let you personalize it. So even if they're not tracking you, it's kind of a lightweight form of tracking that no one objects to. And then they allow cross-site requests. So you can do Facebook like buttons and Twitter, and it adds a lot of functionality to the internet and makes it more dynamic and fun. And then the flip side is that your session cookies end up being kind of like a password. Usually they're not quite exactly the same as sealing a password because there's some things that, like, for example, if I seal your session, I can log in as you, but if I go and try and reset your password, you've often seen it probably where it's like, you want to reset your password, tell me your old password. And you're like, well, why is that? Like, I'm already logged in. I can do everything anyways. Why is it asking for my password? And it's to prevent this. So if I get your session, I'm privileged enough to do a certain number of actions, but then like administrative super actions like changing your password and things like that, they require the password again so that someone that hijacks your session can't like permanently lock you out, okay? So that's why like even though you're logged in, sometimes things require your password again. And you think, oh, it's a sensitive task or whatever, but it's specifically so that a session hijacker can't do it. They can do a lot of damage, but there's certain things that they can't do with just a cookie as opposed to your password. And then you can track users across sites. Okay, any final questions or comments? Okay, good. So we'll end a little early, and next class we'll talk about a different browser policy that's sort of similar in flavor, which is called the same origin policy, but it governs like JavaScript and what it's allowed to do as opposed to cookies. All right, see you all in 2 weeks, remember, so next week's a holiday.